All right, hello and welcome to GLOBEBUSTERS Season 14, Episode 2. Today I'm joined by Shane St. Pierre, ManofStone, Cami, and Karen B. All right, hello and welcome to GLOBEBUSTERS Season. Oops, a little echo back on my end. Today, Stone's going to be presenting on Shadowsets. Stone, whenever you're ready, sir.
Yes, thank you. I'm just doing a send right now to you, Alan. So you have the PDF if everything else fails.
Gotcha.
So that is done. Okay. Hey, gang. It is I. Thanks, everybody, for coming. Hey, you want to get to it? Let's get to it. This is all about stuff that's been out there for the Globies to examine for a couple of months and haven't heard much from the Globies about this. So let's take a look, Cal. We're going to share our little screen here, and that's the one right there. And now you can see the title page, yes?
Yes, sir.
We can. No
Okay.
pressure at all. Okay.
Good stuff. Okay. This is my favorite kind of scenario because what we're doing here is we're relying on empirical data. We're not looking at formulae. We are merely examining what is observed, and it's the best kind of observation in my opinion, because we're not using any special instruments, no tools. We're just using a little basic math in the angular analysis of the measurements that we're taking. And it's really that's all there is to it here. And I stress that to the crowd so that they see the kind of approachability there is in this setup and how they can contribute. And I'm still waiting to see contribution from either side in terms of replication of what I'm about to lay down. And I again, can't stress that more strongly. Guys, get out there and get the data. That's the mantra. Let's see if we can start to live by it. That would be just awesome to see. So starting off with the title Shadowsets. This is all about what happened a few years ago. 3 or 4 years ago, a YouTuber named WJB. He started up a channel, and the channel is called Shadow Reveal. I invite you guys to check it out. There's not very many videos there, but it's still up and really valuable to see the background behind what's happening here today. He put together a couple of visual representations of what it would look like for light during just before sunset to come through a window like of your house or whatever it is, facing west, and then through the window, the light hits the opposing wall inside that room. That would be the east wall. And what he did was he drew up a scenario for how that would look in a flat Earth scenario. And then he also did the Globie scenario. And he's done a brilliant job of side-by-side modeling of what would happen when the sun just does its thing and what that would look like in terms of objects he's placing just outside of the house, et cetera, et cetera, et cetera. So let's get into that. In fully comprehending the scenario, you'll see right off the bat that he's starting with the sun, and he's talking about the two different paths that the sun would be taking in the two different scenarios. So if we zoom out a little bit, you can see the contrast here. One to the next. Okay, Globie on top. So page 2 is showing precisely this. And overall, I think WJB did a great job. But one thing he didn't really toss in, and it's just more extra effort, you know, call it what you want. He didn't provide a graphic like this one to explain the difference in the sun's movement, model to model. So what we're looking at here in the Globie example is that the sun is much farther away compared to the flat Earth example. And this is why the lines look the way that they do, the two lines that I've drawn on each of these images. So we treat the downward movement of the sun in the Globie example, which is the first one, as a straight line. And this is an argument that comes up in flat Earth debates a lot. What do you call a line that is the circumference of a circle when the radius is infinite? You know, the point being that there is no such thing, but if there were, there would be no measurable curvature to it. It would appear flat. So in the same way, we're talking about the sun, which is 93 billion miles away in their example, where it would be something that's moving across a radius, there's tangential movement here, but the chord of that essentially becomes a straight line path downward. So that's what we're going with here in terms of the lines that we're drawing and showing where the sun's going from A to B to C to D, which you're also going to see. The real word here is parallax. And if you look at each of those thin lines, 2 on each one, the midpoint of each line is what we're calling the vertex. And the lines themselves will be changing in angle, but those vertices will remain fixed as time is going by. So in the 2 of these, the vertices are at the top edge of the pillars and outside the buildings, and also the top edge of the openings of the window scenario. So that's a key position for the rest of the analysis, is just where that the vertex sits in each one of those. So off we go to page 3. And here we are. Let me zoom right on in so you guys can see it nice and big. These are frames taken from WJB's video. And at the starting point in the A frame, that looks like just where we were on page 2. That looks exactly the same. That's the starting point, so to speak. This is going to be X number of minutes before the sun actually comes down and hits the horizon, or appears to. So in frame B, as the sun begins to set, so to speak, the pillar shadow has come across the ground and it's reaching the building, and then it begins to cast a shadow on the wall as it moves up the wall. You see, this is the seesaw kind of effect where the sun's going down and the shadow is going up on the wall. The window shadow on the east wall shows that the pillar shadow is just slightly above the height of the bottom of the window opening. So now you can see it just on the east wall in frame B. This is a crucial difference between the two scenarios. Here, in the Globey scenario, the sun appears to be below the imaginary line that we're drawing from east to west, from the bottom edge of the window opening to the top of the pillar. That line extending out toward the sun to the west. This produces shadows on the east wall, which are physically higher than the pillar and the bottom edge of the window opening. In this scenario, we're going to see a distinct difference between those 2 points. So over to frame C, when the sun appears to cross the horizon in the distance and the Globey Earth ecliptic, as in the shadow line produced by that, is non-local, and it begins to rise up to match the height of the pillar. The window shadow is now clearly higher on the wall than the actual window. And when we move to frame D, the ecliptic produced by the sun dropping below the horizon and that particular line coming in overtakes the height of the pillar along with the height of the window itself. And all movement of shadows on the east wall in this scenario are now moving up at an unchanging proportional rate relative to the rate at which the sun is going down past the horizon. So there is no slowing of the rate of the shadow's upward progress on the wall because of the kinematics implied in the heliosexual model. The sun's distance is not changing. The sun's rate of movement across the sky isn't changing. So throughout the scenario, the brightness contrast between lit and the dark areas is still very high. There's a fair bit of contrast there, even at the end of the scenario. And the outlines of the shadows are always crisply defined. And that's something you also need to keep in mind as we go from scenario to scenario, and even as we go and look at the real data that I have to show you here. Keep in mind that in the Globey scenario, even as we approach frame D, right at when it's almost all over, what you're looking at on the east wall in terms of the shapes, the lines that define those shapes are crisply defined, as we can see in frame D. So let's see the contrast on page 4. Again, starting in frame A, that's the starting point for the flat Earth scenario. In frame B, when the post shadow, the pillar rather, shadow, begins to climb the wall, already you can see in frame B that the house is not so brightly lit as it was for A. The window shadow is still approaching the vertical height of the window. Like it's not quite as high yet. So when we move to frame C, when the rate of movement of the pillar shadow, the upward rate that you see it moving up, begins to slow down, it comes to a complete stop. And the ambient light is still darker. So you can still see it defined on the wall. The pillar shadow approaches, but never meets the same vertical height as the bottom edge of the window opening. So moving to frame D, the lit part of the east wall should be a bit darker. It should be a little closer to ambient brightness than what he's drawn here. There's not a lot of contrast between frame C and D in this modeling, but you will see that ever more so in the actual data. I think that's important to point out. So off we go to page 5, and this brings us to the real data. So we're setting the scene here. This is all about the empirical. This is where we're getting the data. So we're looking at a top view of the building, which we saw in the modeled scenarios. And from the east wall, which is on the right, because this is north up, going westward, out the window and towards the sun, the azimuth, the heading that you're on there is 252 degrees. Time of year being what it is when I took the measurement, et cetera, et cetera. It's that particular line is 18 degrees south of due west, as in to the left of due west when you're looking at the horizon. The camera that I'm using to collect the data is positioned in the room directly west of the east wall shadow, and that's where this angular line hits the wall on the right. So draw a horizontal line out to the left from there, about 3 and some meters away, and that's exactly where you'll see the camera. And as far as height goes, it's near the same height as the start position of the window's shadow's bottom edge. And at the top of the image, you can see there's also a rather large window on the north wall. And we're going to come back to that later too. There's some effect to be observed. So notice the north designation top right. This is a Google Earth shot. So here we are with the Google Earth shot. Top right, we're looking at north. Right top there of the image, same orientation of everything that's being presented here. So you got a yellow line. There's a bit of a valley in between the endpoints of that line. As we come away from the house on the right and we move through here, this is all lower in terms of altitude. And then it comes back up this hill. The drop in the middle here is some 42 meters. It goes from 212 down to as low as 170 meters of altitude. That's for the empirical guys, or the imperial guys, that's 137 feet downward from my altitude, which is actually a good thing in terms of the observation when it comes to any kind of land-influenced visual margin of error, something the Globies love to point out when we do scenarios that are down close to sea level on the water, et cetera, et cetera. It's always the land is in the shot visually. Here, it's not. So there's a fair bit less interference of the light path along that line than if the topography were flat in between. How's my audio? Everybody hearing me good?
Loud and clear, bro.
Good.
Excellent. Okay, off to page 6. Let's look at some of the data. This is officially recording number 1 that I showed to the public in November of 2024. Yes. And the graph, what you're seeing in each frame, is only representing vertical downward component of the sun's movement over time, plotted minute to minute. So the lateral movement of the sun is not so relevant. You can see that in how the sun's motion is tracking across the wall at an angle slanting off to the left. That's fine. On the graph, that's not represented. This is only the downward movement component of that minute to minute. So the way I've placed the graph on the image here in this particular recording, I've lined up the bottom of the graph with the bottom edge of the window's start point. So it's literally taking the lines straight across from the image onto the graph itself. So you know there's less, shenanigans going on. You're getting the straight data. Okay, so notice the change in the shadow's brightness from A to D. The shadow itself, the actual semicircle that's being traced here, that is happening exactly as WJB models or a model predicts. The resultant plot shows essentially a straight line for the first 17 minutes of this recording. There's a slight dip at the 11-minute mark. I'm thinking that is likely due to some cloud passing by, causing some distortion or diffusion, where the resultant shadow on the line on the wall gets a little less crispy. I'm sure you guys can see that in your minds. What's going by takes us to frame C when we're 20 minutes in. This is roughly where the downward rate of motion of the sun slows down, just like in WGB's model. And that takes us to frame D a minute later, as it has slowed down a fair bit and is fading out. So the downward motion here, as it's fading out, is actually falling to zero. And that's what you can see on the graph. In the zoomed in part, a little farther down, let's bring that up. There you go. You get a closer look at just what's happening, near minute 20 there. So the rest of the ambient brightness on the wall is coming from that north window I mentioned. The sun outside is still ionizing the gases in the upper atmosphere, argon, xenon, krypton, neon, etc. Even so, you can still see that the ambient brightness going from A to D is also darkening with the departure of the sun. So there's a bit of part and parcel there in what we're seeing in terms of total brightness. The globies, when I presented this data, were simply totally unsatisfied with this level of documentation. They wanted to know several things about the environment and the conditions immediately outside the house and off to the west of the building. So that's what we gave them. We gave them lots more detail in another observation. So let's see how we can square this up. Let's just top with the top 4 right there. All right, page 7, here we are. I think that's page 7. The camera, months later in February, is still in the same position, but it's a little bit more zoomed in than the November example. And this gives us the ability to more precisely measure in frame D the vertical distance from that red mark I put on the wall to the ground. Differently from the first observation, where we vertically aligned the graph to the bottom of the window edge and leave position 0 with the trace. This time, rather, I leave position 0 on the actual image from image to image and successively added marks going up the page minute to minute. So because we are also zoomed in here a little bit, we're seeing a little less of the ambient background influence on the overall image brightness. This is a function of auto gain in your camera, which is typically by default set to automatic. So you're not constantly changing your exposure to match things as you walk down the street or go in a tunnel or whatever you do as a user. So starting from A to just before frame C, on the graph, we see a reasonably constant rate of downward movement. And that's something we observe in both models. But here at C, we're already seeing a slowing of that rate of movement. And on the resultant graph, that starts at 22 minutes. And more clearly, you will see it down here in the final 5 minutes in that overlay. Here, I have merely inverted the data points in order to match the actual downward movement of the sun that we see when we look out the door. So the light blue line, which you can see right about here, let me zoom right in. There it is. The light blue line, this one right here, is an extrapolation of that slope, which you see for the first 22 minutes. And that serves to highlight the beginning of the departure from that constant downward rate. And that takes us to frame D, again, where the downward movement has almost completely stopped, and the sun is fading out during that remaining minute.
Does the globe
up
call
there?
for that? Is the globe predicting the sun to do that, or is that directly against what the globe
Negative.
would call for?
It
Oh,
is
okay.
exactly opposite to what we saw in the Globey scenario, where things were crisply defined. And I'll be coming back to that momentarily. Absolutely.
Okay, and we're gonna stop you a minute. Karen, do you
Sure.
understand where he's going with this, or are you following, or does it?
Yeah, I'm familiar with the shadow stuff.
Okay, I am not familiar with the shadow stuff, so I'm coming into
Okay.
this new, and I am
Hmm.
saying coming into this new, without an overview and without, because you keep on referring to Deb's numbers and that, I am saying that for somebody coming in new, I'm a little bit lost. I usually follow better on exactly where you're going with this, or an overview of what, in other words, you're throwing data and showing pictures at me, but I'm feeling stupid. I'm feeling stupid here,
Okay.
John, and I'm not usually feeling this stupid, but I just want to know where you're like I know you're showing the data in that, but can you give me a more of a
Yeah, an overview.
top down? Yes.
I can. And I was hoping that I was establishing that at the beginning, that we're talking about a sundown scenario.
Mm-hmm.
And if you recall way back closer to the beginning of what I was doing, and I'll even bring it up so people can see it again, that this is it right here for the globies, right? This is my window on my door
Mm-hmm.
on my west wall of my building. And the camera is about here, looking in this direction at the east wall, looking to the right in this angle, right? We're actually looking at a top view originally, and then the camera is placed here, and it's looking to the right where the shadow is going up the wall
Right.
as the sun is going down. So there is a seesaw effect at this vertex point here and this vertex here, which showing the top edge of the window meeting the top edge of its shadow point on the wall, meeting the sun out here. This line will come down with the sun. The vertex will not move. This will come up proportionally. You see?
Like a seesaw. So I do get that. Okay.
Yeah, there's a seesaw effect here. So the difference is that, sure, the same seesaw effect here is happening, except the sun in the FE scenario is moving horizontally.
Right.
Is just moving away. It's not actually moving down. But because of the laws of curved visual space, we see it very far away, still moving farther away to us, just like a plane flying at 30,000 feet directly over our head in this direction. When we look in this direction, it appears like the plane is approaching the horizon. It looks like it's dropping in the sky as it gets farther away.
Yes. Angular
That's just curved
resolution
visual
built
space.
in. Yeah.
Right.
It's also
So
built in with your eyes and your filters and
right.
the angular
So
resolution. Yes.
what we're monitoring is the difference when it continues to go away and the shadow approaches the house and goes up the wall from the outside. And in my case, I'm actually videoing what happens from here between the bottom edge of the window that starts on the floor down here in both scenarios. And then they go up the wall as the sun does its thing. These are the globe examples for how it looks. That as the sun sets over on the left, this vertex produces an upward angle as the sun now is lower, way off to the distance, approaching between this height, altitude rather, and the altitude of the horizon, far in the distance, as the sun eclipses it. So the difference is we're seeing in the Globey model that this vertex, this point here, as the sun gets lower, it gets higher than the pillar on this wall. In fact, because the pillar and the bottom edge of this house are at the same altitude, the pillar shadow then begins to flow through the window, and you also see it on the wall at that point in time. C is about another minute after that, where the sun is even lower and on its way out. Again, upward angle as this shadow goes up the wall faster than this shadow goes up the wall, window to wall, you know what I mean? Because this distance is greater, right? And in the D, actually the C and D scenario, this line is the Earth ecliptic. That's the terminator line between the sun and the Earth. That way over on the left, as it's still going down and part of the sun is now no longer visible, the Earth ecliptic there's a vertex line between the surface of the Earth out here at the horizon, and it's going up here and overtakes both of those shadows because it's moving even faster because it is even farther away from that vertex, if you know what I mean.
Mhm.
That we've got this rate, which is pretty slow, or actually, rather, what we have is the window rate, which is the slowest because the distance between them is proportionally very low compared to the others. The pillar to the wall, which is larger, so it's moving up faster than the window shadow is. And then the Earth ecliptic comes across and beats both of them.
Wait, so the globe prediction is the shadow should speed up as it sets, not stay constant?
Yeah, the globe prediction is not that necessarily the pillar or the window shadows should speed up. It's that the ecliptic rate of movement up the wall is always faster than both of those. That it's A, B, and C. A being the window speed going up the wall, B being the pillar shadow going up the wall, and C being the Earth ecliptic line going up the wall faster than both of them.
Right, so it should never hang up and go slower then, the opposite of what you're
Exactly.
showing. Okay.
Nothing ever slows down, nothing ever changes rate. Because the Earth is spinning and yada, 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 yada. Well, the difference in the models here is that as the sun just goes away in the flat Earth model, the shadow comes up the wall, this one goes up the wall. But because this pillar height and this window bottom edge height are the same altitude, and the sun doesn't go below them in the flat Earth scenario, it goes away. Geometrically speaking, that vertex never inverts like the globy scenario. There is no upward like this in the flat Earth scenario. It comes up the wall, it slows down, and then it stops here before it reaches the actual height of the bottom edge of the window opening. So you never see this shadow in here on the east wall. You never see an Earth ecliptic line shadow come up the wall and in the window, and you see it on the wall. You don't see any of that in the flat Earth scenario. Is that clearer, Cami?
100% now. Thank you for running through it
Okay,
again.
excellent.
I got lost in so many of the details that I forgot the story, and part of that
Yeah,
is
no problem. No problem.
being
Glad to
outside
go
there, but
back to
thank
make
you.
it clear. That's
the sun-
that's what it's about.
That was a great
sun never-
rendition. Great.
Right? It never goes below the surface of the Earth. That's what
Mhm.
we're talking about, and that's what we're showing, and that's what's
Mhm.
required for the globe.
Mhm.
Got it.
Exactly. You have to have this in mind, that the sun's doing that instead of that. And what effect is that producing on the wall? What observation are we going to make? And in November, that's exactly what I showed. That when you see this line slowly level out instead of staying the same slope the whole time, that's confirming that the sun is going this way, not down. That's the difference between the two scenarios. So now we're taking you to the more precisely measured, well-documented version that I took in February. And again, the same thing's going on, except I didn't put this graph down low at the starting point because I'm zoomed in and this takes up far more of the image. You know what I mean? I had to put the graph up here. There was just no space in the image to do that. So what I've done, and let me zoom in right in here so you can actually see them. Here, see all these cute pink little X's? The final one being drawn right here, if you guys can see that, that is a line. There's a little teeny black line that comes out this way and a little pink X, and it's all one group composite overlay. All of this black tracing and the pink X is exactly what we're looking at when we start in frame A. In frame A, it's there. Can you guys see that? That little teeny line with the little pink X right there. That's point number 1, or 0 actually, minute 0 here, and the little pink X is right there to represent it. And we move over to here. Here are another dozen pink X's as it has made its way up the wall. The shadow is literally moving in this direction, and this is the vertical component, which you're seeing here. This vertical height change is parallel to this vertical height change over time. So we're 12 minutes in at this point. The sun is so far down outside. You see what I mean? That it goes from A and it goes higher and then it goes higher and then it just stops and fades out in D in minute 24. And this is what I've shown here, that the blue line is the extrapolation of that slope. This is what the sun's movement would have been doing in the globy scenario. However, this is what we measured. We measure a departure. We measure a curve away from that slope. We measure a slowing in terms of the vertical component of movement. So that's kind of where we're at there. Is that clear, you guys?
Yep.
I love it.
Okay. So let's talk about page 8 for a second and to deal just with frame D here. Okay. Here we are with frame D. And I don't think we need to go any lower than that right now, but that's it right there. Everybody sees that image, I'm sure. Okay. The top frame up top here. This is literally when the sun's movement on the wall in terms of upward movement is coming to a full stop. And this exposure here is midway through it fading out. That's the moment in time at which this frame was taken. So then there's this red dot. That is a round piece of plastic with a magnet glued onto the back of it. You know, it's a fridge magnet to hold up your kids' artwork and stuff. Just pin it up and there you go. That puppy there is 30 millimeters in diameter. So 1.25 inches, 1.5 inches, and somewhere around there. All right. The center of that red guy is the same altitude as the bottom edge of the window opening in the west wall, in the door where this window is mounted. So we're taking the same height coming across the room and plotting it on the wall so that you can see, just like we were looking back at the beginning here, where we were talking about, well, what about the height of this window edge and the height of the shadow on the wall, which is, if you look really close, let me get you over there. You can see that this is ever so slightly lower than this. In fact, this never reaches the same height as the opening itself. And the question is, how close do we come? And that takes us down where we're at with the secondary set of data, looking at the final frame and this dot on the wall. Right here is the height of the bottom edge of the window behind us in this shot, over our right shoulder. 252 away. And the distance between that and the line that we measure on the wall as it's fading out is 117 millimeters. Cool, hey? But what does that mean?
Can we make a triangle with it?
Yeah, I sense an angular calculation coming up. Okay. Okay, so this is all about the vertex, which is the bottom edge of this doorway window. So the angles, let's go back forward rather. Let's take a look at this guy. This is the stuff we're producing with that. You got the wall on the right. You got your ridge peak on the left. And you got your doorway in the middle. That is our vertex right there. Okay, angles here in this are shown as proportionally correct, but the distances are not to scale. Okay, so the distance of the light path here is from the ridge outside that I'm going to show you in terms of, I think I did already. Did I not already cover the topography? I did. We went from 212, we were down X meters and then way back up to 228 meters along this ridge over which we're seeing the sun disappear way over here. So for me, this is kind of my pillar. And for me, I will cover again that this pillar is not the same height as the window edge. In fact, It's 16 meters above. And that is the green over here. So when we zoom right on in, and I'll actually take you a little closer to this in the next frame, but there's about where we're at. Again, here we're looking at 16 meters. There, let's start with the black line though. What does the black line mean? This is the one that is the same altitude as the bottom edge of the opening in the window. Straight across, same altitude. So we look at the ridge, it is 16 meters above. And if you look at the numbers, you'll verify that. And again, to the right, let me get back to my notes here for a second. Same azimuth at 72 degrees if you move from west to east, or 252 if you move from east to west. Just like the yellow line that I showed you on the Google Earth graphic. Black line, same altitude, 1,400 meters to the west, 16 meters, actually rather 16 meters above, I should say. And that is a departure, like I was saying, from the WJB model, who used pillars that are the same height as the bottom edge of the window. So technically, not even technically, actually, physically, we're leaning to favoring the Globey scenario, that we should see even more so by a factor of 16 extra meters of height. We should see this shadow, if the Globey scenario is correct, we should see that 16 meters come through here and produce an ecliptic, produce a second shadow, a shadow of the ridge, if you will. We should see that on the wall, but we never do we? All we see is the outline of the sun. We see a complete shape. We never see half of it cut off by the ridge coming up and you know what I mean? Turning it off. All we ever see is it slow down and stop and fade out. Yeah, we don't see the Earth overtake. That's the point. Okay, red dot, 117 millimeters. We got all that.
I forgot about that little detail stone. That's so huge. There's no little baby ecliptic there, even in the best case snenario for them.
Yep.
It doesn't happen.
We're helping them out by 16 meters. You know what I mean?
Embarrassing.
And we're not seeing any of that. So back to the image here. Again, that's the 16 image from same height of the window up to the ridge. So what's the red line about? That's the calculation that we're making with that 117 millimeter drop on the wall between the actual height of the bottom edge of the window and how it is projected on the wall. That produces this 0.995 degree angle. And that is this here, the red to the door, back to the wall. This angle here, almost a full degree. 6.7 meters across the room. Okay, out to the west, that's 1,600 meters, or 1,400 meters rather, away, 16 meters up. That produces the 0.655 degrees, as in just about 5/8 of a degree. So we have nearly a degree here and 5/8 of a degree here. Subtract one from the other, and you get the difference of 0.34 degrees. That is the significant figure in what we're talking about here. Just over a third of a degree when we're looking at the sun allegedly dropping below or towards or whatever you think, the horizon. This gives us that angle.
You're talking about the actual solar diameter is 0.53 degrees as viewed from anywhere, and you're taking the percentage of that. So it sets completely with 70% of the sun visible above the horizon. Is that what you're saying?
It looks just like that zoomed in. That's the left side of that image, and I've dropped the sun with a proportionality here that this is hitting it at 70% of the way from the top to the bottom, if you know what I mean.
Wow.
And even as that comes to, you know, this is again where we're kind of helping out the globies a little bit. That when people talk about the angular size, the apparent angular size of the sun, they round it to a half a degree. It's a couple arc minutes each side of 30 arc minutes across, right? Okay, there's your zoomed in angle, and that's why we're looking at this. The black line, again, this is the bottom edge of the window in terms of its altitude, and the green line, which is the ridge, 1,400 meters to the west. The red line is the top edge of the sun, okay? Following the red line through this image, the red line coming down, hitting the vertex, it will tell us here, the lowest point, what exactly is happening with the highest point over here. This is how we get this 117 millimeters. That the top edge of the sun over our shoulder is hitting the vertex of the window, the bottom edge of the window here, and still going downward to here. That's producing the angle for us. Now, about that 70%, like I was saying, let me get to that point in my notes so I can word this effectively for you. Okay, as a fraction of the commonly accepted angular size of the sun, that should precisely represent only 68% of the sun's size. But many of us have seen countless video observations of the sun as it approaches the horizon, where we see that the vertical height, the apparent vertical height of the sun is compressed. Not a lot, but if you look at it digitally, you can plot it out and you can measure that. But it's in this particular case, it's significant enough that that amount of compression would actually represent more than 70% of the apparent angular size of the sun here. So I'm kind of rounding down to 70%, if you will. So again, in terms of the measurement, we're actually leaning to favoring the globies in terms of the figures that we're adopting here. Can you see how that works? That if this wasn't perfectly round, the top edge is still the top edge is still the top edge. If this wasn't perfectly round, if this was actually closer to here, then that would be closer to 80% of the total sun visible over top of the green line. Does that make numerical sense?
Yeah,
I'm
so you're
sorry.
just basically taking the percentage from the visible diameter. of the sun.
We're saying that when the sun's way up in the sky, and say we're measuring it this way, for example, that this is half a degree, 30 arc minutes across in terms of apparent angular size. But as the sun approaches the horizon, atmospheric effects cause vertical compression of the apparent size of the sun. So this will start to look more like a football. You know what I mean? It'll be squished, vertically squished. Well, if we're talking about proportionality and we're squishing the vertical component, that drives this number up. We're seeing more of the sun, and because it is squished, less of it so far is obstructed by the peak. Hope that's making sense.
And just for comparison, what's the equivalent globe prediction for percentage of the sun above the horizon when it sets?
Well, that's the thing. What you just said technically was oxymoronic.
Yeah, yep.
Isn't it? Because it can't be
Zero.
above the horizon if it's setting.
Yep.
It's going below the horizon. It's disappearing at a constant rate. It doesn't matter if it's squished or not. It's still going down to 15 degrees per hour, according to the Globee model. So this is irrelevant in terms of the Globee scenario because, you know what I mean? This doesn't happen in the same way. The proportionality is completely different with respect to time. If that makes sense. So we're nearly at the end of what I'm presenting here. So I thought at this point I would discuss a refutation or two. And during my description of the Globee scenario back on page 3, let's just take you back up there. There it is. I mentioned that shadow outlines are crispy in frame D as the Terminator, the Earth Terminator, comes up and overtakes everything on the wall. That everything here is crispy. But in the data, in the recordings, when you look at them, here we are. We see that the shadow outline on the wall is crisply drawn as the light intensity drops to 0. But here, as the light intensity does, then this is less and less and less discernible. That the amount of ambient light coming in from my north window begins to equal the intensity of the light still coming through the door because of the sun's presence. So there is zero indication that any part of the physical objects involved are being eclipsed in the least. This tells us that outside, the sun's shape is still also just as crisply defined as it fades out and is no longer discernible because of the opacity value of air as it moves away. It just fades out. And this is something that I showed in the video I produced of all of this data and released the first week of March of this year. So if you guys buzz over to my BitChute channel, and I'll show you the links to that in a sec. Well, actually, not the link to that, but all the rest of my contacts. Anyways, if you head over to BitChute, those of you in the UK, I guess you'll have to VPN your way in there. Ironically, that it's a UK corporation operating in the UK, yet people from the UK cannot visit the site. Anyways, VPN your way in there and just go up to the search field, type in all one word, ManofStone. My channel instantly comes up alone, and you will find the Shadowsets videos there. Again, chronologically ordered in BitChute. By all means, watch this one that came out in the first week of March.
Oh, by the way, shout out to the UK. Y'all, because of your recent laws passed and the different things you're doing on verifying adult content on like pretty much everything and putting your licenses in, and the good job that you guys are doing, like holding the security licenses. I'm sure you guys have heard of the security break. VPNs are now, the programmers are all laughing. VPNs are all now, right now, they've eaten up all of the top apps, sales and that trending right now. What apps are trending? It is all VPN. They got took over. So congratulations, UK. You guys did that.
Yes, way to act. Good stuff. So in terms of what I'm presenting here at the end about the sun being crispy and fading away, that is what you will see in the final frames of the video that I produced and released the first week of March. It's from Dave Weiss, when he famously took his drone up the top of a mountain and even flew it another 150 feet in the air above his own head and used the camera on it to just real-time videotape the sunset. And he did it during the winter, so the air is cold, the lapse rates are far more favorable, there's less distortion, it's a straight up view, and there's no hiding the dog on this one. You're looking straight at it, you're looking at a fully developed round shape of the sun disappear into the clouds. It does not drop below the horizon, not even a titch. And I release all this, I send it all out, and the Globies, of course, claim that none of it is true. And the only remaining objection that I've received by Globies was, again, that I'm still under-documented, if you can believe that. They don't accept this as evidence of anything of the sort, since I also didn't take simultaneous video of the sun's motion as viewed out the window to the west.
The sun didn't set that day. You faked it, bro.
So
that's right for you. Yeah.
They absolutely can't look it up on Sun Calculator or the history of the movement of the sun that moves in a circle in perpetuity. They can't reference it at all. They need the video, huh?
It's simultaneous video or it's all fake, like TFE.
Fantastic.
Yes. So when I get responses like that and nothing else, I am left to conclude only one thing, and that is, when it comes to proving anything to the Globies, there is no such thing as enough.
So what's funny is they bring up something like Mount Rainier in the shadow as proof, but then not accept this as a debunk. Right. So if we're talking about rising shadows and Earth ecliptic that isn't there, that should be there in all things, right? They'll accept evidence of that it's actually, look, you can see the bottom of the Earth, but never during any sunset would that coincide with any empirical observation.
Yeah, I see a lot of objection, a lot of not satisfied. You know what I don't see? Replication All I hear is unintelligible noise from armchair cowboy zealots. And yes, that is a brazenly worded challenge, but it's the same one that I've issued countless times in the past. My response to these kinds of reactions is, if the Globies ever finally do get around to attempting replication of this data, they had better make sure that they are also taking simultaneous video of the sun's movement as viewed outside, or I won't accept it. You know what I mean? If you want to make the demand, you also have to meet the demand. Let's just put it that way. So do anything less, I'll be laughing at them. And that's pretty much the end of where we're at with this presentation, guys. And that's the shot right there. If you're still looking at my screen, that is one of the final frames that I show in my video of the Dave Weiss footage. You can see that puppy. He's round. He's not touching the physical horizon at all. In fact, he kind of illuminates some of the atmospheric interference. You can see that when you look at the horizon line, it dips where the sun is. It kind of looks like Einsteinian representation of space-time, doesn't it? A little bit, ironically enough, yes. But this is literally a fraction of a second before the entire sun fades out as a whole in that video. You don't ever see half the sun.
Well, but that's because of atmosphere, though, right? You said yourself that the sun disappears behind clouds.
Yeah, it disappears behind the pure opacity value of air. And yes, we're looking at it horizontally, so the effect is maximized.
But my point is, though, because there's a couple of things with this, like it's a good presentation, but there's a couple of things I have a little bit of contention with. I will play devil's advocate.
Sure. Yeah, go right ahead. What you got?
Okay, so when the sun disappears behind the clouds, you're not truly seeing it to the end of the point of perspective. So those two horizontal planes are still not ever meeting, where I feel like if you were to observe that without any atmospheric interference or no, air, eventually the sun would sort of like meet the ground and one would go into the other. So I don't, for me, I don't really think that that's really a proof either way.
Okay, so right at the back of the beginning, you mentioned clouds, but there are none in this scenario.
In which one?
In this scenario that I've got up on my screen right now, where Dave videoed the sunset, there are no clouds there.
But okay, well, you did say that it went behind clouds.
However, no, I didn't. I did not say that. No, Karen, let me check you there.
Something that went behind clouds. I don't know.
Not at all, Karen.
It disappears behind the clouds because what I think is going on is it's disappearing into the atmosphere. Like there's atmospheric obstruction because it's not 100% clear.
Yes, that is what I said.
Especially horizontally. So it's like, I think that makes the sun disappear probably faster than it would if you were to let it extend completely to the point of perspective, right?
No, I don't exactly know what you mean there. That was a lot of salad. What we're looking at here is a single effect. There are no other variables involved here. We're looking at a cold air mass. We're looking through a cold air mass at the sun from elevation, right? From a couple hundred feet up. And all we're witnessing is the effect of the density of air, the opacity of air. Its raw value, and enough air is coming in between us and the sun such that its energy is no longer able to penetrate that mass.
Okay, but still my point is, okay, so my question is, in the very first slide, when the guy does the modeling, what program is he modeling it in? And does he add
does that
atmosphere?
matter?
Yeah, because does he add the atmosphere into that? Because you make a point to say that the lines are crisp, specifically in the globe one.
Yep.
But the globe has an atmosphere. Like I'm just saying, in their model, they have an atmosphere.
Okay, I understand the question now, and let me address it. You see, in the Globey scenario, which I'm showing right now, it was the very first thing I pointed out back here in the difference. The Globey scenario, that this we perceive as downward movement, although it is actually allegedly an tangential movement, isn't it? Right? But the point is, the distance between the sun and the observer is static. It's just a radius value, right? Here, it's the opposite. Here, it's a raw distance value because you're looking along the horizon. In fact, there is no other component. That's why it slows down and stops going up on the wall, because it's not really going down anymore. The proportionality of the trigonometry of this situation, the trigonometric truth is that as it continues to go away, it's not really getting any lower in physical space. So this shadow is no longer getting any higher. And that's what we see.
I get
on
it.
the
I don't
wall.
have a problem with the movement
Okay.
of the shadows. Like the movement of the shadows, one versus the other. I get that. My contention is a little bit like the crispiness. Like I feel like the sun would fade in a globe model too, because, and this is, obviously I don't think this is true, but if you're on the edge of a globe and the globe does, they say the globe has an atmosphere that sticks to the surface of the globe. So like as it's turning and the sun, your angle viewing the sun changes and you're looking through that atmosphere, I feel like there would be some fading, or like something would be affected with the light there too, as it's going through more atmosphere rather than it being like over your head.
Some is always a really dangerous word to use, an imprecise, dangerous word. And that's where I stop a lot of people when they pose arguments like that. And really, again, what we're seeing here, the moment before it fades out, is still a crisply defined shadow. That we're seeing all of these lines, you know what I mean? Just like we were a moment before, they're all still there as this thing fades out. We never see this element in the Globey scenario in frame C and D. We never see any shadow from outside overtake the height of this bottom edge and produce a shadow subsequently on the wall of the pillar or my ridge 1,400 meters to the west or anything of the sort. We never see this in any of the data. We see this, although this one is slightly darker than this one the moment later, right, from where I took them. Again, these two heights, the shadow heights, are the same. These two are, this one is ever slightly higher than this one, and both are lower than this altitude here. They never get close, and this is why I'm exhibiting this measurement here, just as it's fading out in frame D, that the difference here and here, that's it. That is as small or short as this distance ever gets before we lose sight of this altogether, before the sun fades because of the opacity of air out completely and ambient light takes over all over this wall from the north window on our left as well. Does that make sense?
Yeah.
It makes sense to me. My only things on it would actually things that can go along with it, like other reasons it could be fading out like that so perfectly, and not just pure atmospheric. We have a lot of things up there. Again, the sun is polarized light outside of it, and we have a magnetic field over, so a lot of it in my mind can even be angles of where you see it and it naturally canceling out light and fading out, and that working along with the the gases being
Okay, well, if
like, in other words, I
again,
have things that add in to make our model stronger. As far as the globe, I see how the rising shadow, I mean, to me, the rising shadow makes perfect sense as a globe killer and proof.
or lack
And
thereof, yeah,
or lack thereof, or
yeah.
putting in like the preponderance of evidence, so that again, it's yet another thing that makes no sense. It should be rising up the wall, and I can see. I think your visuals were good enough, and I'm watching this fresh. I thought your visuals were good enough, and your explanation
Thank
was
you.
good enough to, see and understand that it should be climbing up the wall, and it didn't. And I think that was like one of your strongest points, the crispiness of the shadows. You can play both ways because you can add in a lot of variables and get it or not get it. What you're explaining in the crispness of the opacity before going away, to me, natural effects, not the atmospheric, but again, Faraday, where your fields are crossing and it takes away the light. That does that perfectly. It's like, again, looking through polarized glasses and getting,
Yeah.
as you angle them, a different matter. So I think you have things that add in on the flat Earth model that make it even stronger. The same with it entirely fading away if you look at it as a real focal point instead of a solid, but that's taking advance. So I appreciate the exactly what you're trying to do. You kill the globe, and I forget coming in here. The globe has been shot, nailed, coffin dead so many ways in so many days. And I bring that in coming in, and you guys are doing the hard work and the math and everything to show how it doesn't work. And so, like, I do appreciate that argument a lot. And I think you did a really good job with it.
Thank you.
Well, if I were to put my Glober hat on, though, right, would I be able to
And it-
contend that that delay at the horizon is actually due to obsequious refraction? Refraction, it just refracts at the edge a little bit and hangs up to match what the observation is. So I can have that observation too as a Glober.
Well, don't forget this part here, guys. And it's the movement. It's why I spent time plotting all this graph. Right here, this departure from the slope is not something you see in the Globee model. I mean, maybe just a hair, as like I said, there's a bit of vertical compression of the apparent angular size of the sun as it meets the horizon, but its rate of drop doesn't change.
Right, but you know the graph of the refraction coefficient in relation to the elevation angle would go
Yeah.
up. So it would wouldn't
It's
they just
that.
be able to argue like like we're right at the
There's
edge.
a bit of that.
That's when the refraction gets heavier, and that's why it drags, and that's why it's still a globe.
Yeah,
you know?
okay, but then we have to quantify how far is the departure, and does it ever go, straight across before it disappears? You know what I mean? Does this actually go wee and then flat and then drop off the face of the Earth? Is that what happens? No, that's not what we see in the data. If they had a leg to stand on here, I would be pointing it out. I enjoy that part. You know what I mean? That they might actually have one iron in this fire, but I'm not seeing it. I'm not seeing it in any of the data, any aspect of the data, any parameter, any variable that we pointed out looking at WJB's modeling, where we say, hey, this is what the sun does. This is what we expect that to look like, one scenario to the other. And again, please, people, go to Shadow Reveal's YouTube page and watch this video. It's only a couple of minutes. It's worth it. It just fills everything in, and you get a really good idea about the contrast between these two models and what they look like side by side when you see them frame by frame. Not just the 4 frames, and the pertinent events of the scenario, like I'm pointing out here in still 2D. He actually does a really good job. Go and check it out, and then watch my video because I use pieces of it. I show all of the frames that I'm showing here. In fact, a lot of this is directly from the video production, and this is straight up data. Again, you can see that I've marked these in the corner because they're straight out of the video. Go check them out, gang.
Mhm.
And again, get the data. You people out there, everybody out there, I'm sure at least 20% of you have this physical scenario already as part of your house somewhere. You know what I mean? A second floor window would be even better. Go do it. Go figure it out. I've even had discussions with people on and off about artificially recreating the scenario. Don't worry about how your house is built. Just put up a vertical wall, cut a square out of it, any size you like, and put another wall parallel to it to the east. Get that distance X away that you find it sufficiently you know what I mean? Exactly what I'm showing here in my own house, right here. Here's your west wall. Here's the door. There's the hole. This is the shape that you're witnessing on the wall here from a camera situated here. Anybody out there can produce this wall, and put a camera in between to shoot the wall as the sun goes down outside it. This is all very easily done. I want to see replication of this, gang. Get on it. It's been 4.5 months, and I'm seeing nothing in response. That ain't right. That ain't scientific. That's armchair cowboy tactic. I'm not into it. That's not my MO. I hope I'm making that clear. That I don't want to talk about some and should and a bit and a tad. No. I want to talk about 70%, 16 meters, 0.995 degrees. I want to talk about that. You know what I mean? That's what I want to talk about. The data. Show me that, and we'll just bring this down the street. You know what I mean? The more data points we have, the more confidence we have in our conclusion.
Well, I'm looking because my setup right now is I'm facing out my north wall,
Mhm.
facing directly north, and this is my west window, and I'm watching right now as the shadows will creep up in another hour, will be on me through here and
Yep.
then creep up the wall.
Yep.
Unfortunately, I'm in a valley.
Yeah,
And
them's the
so
breaks.
I'm going to, no matter how hard I do it, but I do find it amazing that, and people don't think about it, that I do come out here in the morning and on the east side, I have my bedroom is there, so I do not have, there's a room there. I do not get to look that way, but I come out here every morning and I watch the sunrise to the north. I'm facing north and it's coming, and then I have to go out the front
Because
door
it's
to look at
summertime
it.
there. Yeah, of course
Right.
you do.
Yes.
hmm
So just beautiful.
All
I'm
right.
doing
So here are my references. Again, Man of Stone is what you will enter when you get over to the BitChute channel, VPN or not, and you'll find my channel immediately. And you can contact me directly on Telegram at Man of Stone, or you can come by and discuss things on the Stone Cold Shoot channel, or you can come by and check out all the rest of my production on my very own channel. This one is actually a group where you can participate. This is a broadcast channel, much like a YouTube page without comments. So that's about where we're at, gang. Thanks for checking out what I'm all about.
Dude, thank you, Stone.
Nice.
Great Prezi.
Any other questions, comments? Anybody reading YouTube to see if there are others?
Nope, there was some discussion of other things in the chat. No questions.
I'm still
Well,
trying to reconcile Stone, and you can tell me part of the stuff the video that you showed from Dave did not show the clouds, but you were talking directly. I'm trying to do on the clouds.
I
I
just
think that
don't.
the confusion came because you talked about the clouds with one picture up without that one, and I think you were talking a
Maybe.
different scenario.
oh, but there were no clouds. That was a
that picture.
shot.
Well, okay,
No,
can
but
I
you were
just say though,
discussing
I
it. Yeah.
still don't think that the drone shot really lends anything to the presentation because it's not in focus for one thing, and it's still a sun. And when the sun gets close to the horizon, it's still, even if it's squished, it's still round. And when the light is so bright from the sun, it's going to appear like a round sun.
Okay, let me address that.
Okay.
I think they
And
said
that
it was
is
pushing down on the clouds.
the frame that I showed just now of Dave Weiss's video was taken literally a fraction of a second before the whole thing just disappears. If you back up the video 2 seconds, you will see exactly what you're looking for: a crisply defined, nice round sun, nice and bright, and all that. I can't show all of that in one frame, right? So I've chosen the frame, the fraction of a second, just a few fractions of a second before it's gone altogether. That's why I recommend people watch my video and see it for themselves. And you will witness exactly what you are wanting to see out of a still frame, but never will.
What do you mean? What is it you think that I'm wanting to see?
You just mentioned that you wanted to see a nice, crispy, round, bright, clearly defined sun shape.
No, I didn't say that. I said
before
that
it
the
disappears.
frame, I said that the sun in the screenshot was a little bit blurry, so it's going to appear like there's a whole disc right there and the light is round, but you don't actually know that it is. And you're saying, oh, well, just a frame before that, the sun was really crisp, and then it was like one frame, and then all of a sudden it's blurry. So why isn't it more
Well, that's the
gradual
point.
than if there's no
It's-
clouds? Why wouldn't it just be it going through,
your
I
own
don't know.
language? The language you're using is actually answering your question, Karen.
How so?
That you're saying the frame I've chosen is blurry. Yes, that is because it is in the act of fading out due to the opacity value of air. It is at that point beginning to become totally distorted and blotted out by the atmospheric condition itself being dense
Right.
air. Not because there's a cloud, not because the air is moving, not because of anything else, only because the sun is moving farther away and less energy is getting to you. So it appears blurry the moment before you can't see it at all anymore.
This one I think we should let go because we're talking about cameras and optics and things. No.
I just think, yeah, it's
With a
kind of
good
weird
thing.
because, like, I took a lot of video of the sun rising over the ocean in Myrtle Beach, and it was very clear, and it just behaves a different way. So it's like, I don't know. I just don't feel like that screenshot really lends anything to the rest of the argument.
Okay, let me check you again. Now, you just said you were at Myrtle Beach. Were you on the beach when you took that shot?
Yes.
That's the difference. You see, Dave was taking this in the winter from a place far more to the north when it's really cold, right? And the atmospheric seeing is entirely different at that altitude than what you experienced. That's apples and oranges, Karen.
Okay.
I think what she's putting in there is, okay, I'm going to help you out on this one, Stone, too, on the different things. I think the proof that you had.
It's also
This is
a
my
different
opinion.
camera entirely.
Right.
Like I have a drone.
Oh, yes.
I use a drone. I've
Yes.
taken many videos of the sun. I'm just saying that effect I don't think is lending to the argument, because I think it's just a matter of optics. It's not really because.
Well, when
I
you
don't
say
know.
it's a matter of optics, I agree that the optical conditions between your scenario and Dave's are different 5 times over. And you're just not
Okay.
seeing the differences in
I don't
how
know.
that's going to
My
result in
video
a
is
different
pretty
video.
Clear. My video is pretty clear.
Again, this thing like pretty clear and a pretty sort of sad, but it was a tad this, but not
But-
quite that. I don't talk about that, Karen.
Mhm.
I'm not into it.
Do you want to
This is
see my
where-
video? Can we show it?
That's not what it's about. Everybody has seen videos of the sunset in both examples, and it's always a factor of observer location that tells you
Yeah.
exactly how that video is going to look. And
This
what you're
is-
telling me right
There's
now
no
is
zoom feature
confirming
on
that.
drones either.
Mhm. Yeah.
So that video
That
is
doesn't
also
matter.
enlarged.
I'm
Yes,
cool
it
with
is,
that.
because the more you enlarge the video, the lower the resolution goes on it.
Yeah,
I
but
think
it's still a clear look at the sun, or it's not. You know what I mean? And when you're on Myrtle Beach and it's not winter and you're not up a couple hundred feet like Dave was, you're getting incredibly different optics.
Okay,
I
this
don't
is
think
where-
You can't
really
compare
makes
those.
that big of a difference.
I'm going to jump in just because of the fact that the optics, the one thing about like the optics and doing it when you're dealing with so many variables of the sunset, people see it go down, people see it disappear. People have taken sunset videos on everything, and I can actually give you different effects in nature that can cause all of them. Different effects that are out there that can actually cause all of the different effects that we'll see that actually are out there in nature. But like you're saying, it's completely observer dependent. It's completely temperature dependent. It's completely so many variable dependents, including the time of year, what your angles are, even again within it being cold. I think it has more variables than even Stone you are giving it.
Yes.
That
Yeah,
for, and
lapse rate,
Karen
for
the other way.
example.
So exactly, you're opposite. So what I'm saying is what's probably bothering Karen is that you're mixing something that I would call your shadow sets of where your shadows are setting on your wall, that you're marking it and doing your angular resolution to, that I would call a proof. I'm going to actually call it a proof. I'm seeing how it's stopping and saying that we should get bigger data sets on it. But if that's true, and I don't, and to me, that is kind of what I seem to observe in life, because I try to pay attention around me. It's hard sometimes when you're in a valley, but I think we're confusing a proof and a set with then doing on a drone shot or different things of sunsets and the optics that you're getting with the sunset that you're dealing with. Again, drone cameras or different cameras, optics, different conditions, and calling it a proof where again, we might isolate that one thing, but like just having a picture there, I can see where, because again, you get into, you guys do, I don't bother arguing with Globers or that, because I really don't care if they I really don't give a rat's
It is a
ass if
null
they wanna believe.
prospect these days, isn't it?
I don't like, I work on like different optics, and what actually to me it's like I am just amazed of like all the different things we need on the optics and how everything is there. Everything is like right in front of us there. Like again, your electrostatic acceleration, all of your different pieces. We can explain monopoles now. We can do so many things. But I will say more than anybody that your optics, I'm your person on your optics. I specialize in optics. I tested things by optics, and I know how easily, again, the optics and what you're working with and the number of variables. I don't think that you can get a proof positive on some of the stuff that you're doing, other than maybe if we build some different preponderances. And it's a little bit harder on your preponderances on sunsets because everybody has a different atmospheric temperature, elevation. It's a tougher where your shadow experiment is better to set your shadows. People can do that.
Well,
They can
again,
do the
that's
cat. So I
that
think
is
we're
why
getting.
that's why I provided the Google Earth
Mhm.
shot in my presentation and the video,
Mhm.
of course, is I wanted people to see that I'm not on the beach. I'm 212 meters up. I'm
Mhm.
40 kilometers from the ocean, and it's behind me. It's to the east. I'm looking to the west. None of that, you know what I mean, is a factor, is a significant factor. The way Karen, it was for Karen's video when she's at Myrtle Beach, when she's down low at 0 instead of 212 meters, when, you know, and she's on water instead of inland like
Okay.
myself. She's looking over water and I'm looking over
Time out.
land. You
But
know what I
on a
mean?
show where you're
Different.
right, but you're not focusing. That's its own prezi right there on what you're doing, because just the idea of of like again showing and doing an isolated sunset and throwing it in is a proof, because we get that throwback. That should almost be it should be something where you're showing your experiments, and that's what the show should be about, because you're controlling different ones, and you can say under this controlled environment, this is what I'm getting.
I used Dave's
She
footage
wasn't arguing
because,
that. I think she was arguing just having one thrown in there because
right.
and I
Well,
think we're
I
on
wouldn't
going too far
necessarily
on
use that expression thrown in. I adapted it
demoed
directly
it.
because his conditions were very similar to mine. I mean, winter versus summer, sure, that's a big difference. But the point is that altitude is a significant factor regard optics of and visibility and what you're going to see in the distance, how clear things are going to be, how far away. You know what I mean?
Were you in
I'm reducing
Uruguay?
a lot of that and all the
Right.
air mass problems you have by being at the beach.
You have some other variables too. You're at very, very different latitudes, and again, very different conditions.
How's latitude going to make it different?
When we get into
I'm
magnetic fields and
seriously.
doing things, yeah.
Where are you for north there, Karen? What's your latitude north?
35.
I'm at 32 and a half. 34 and a half. So no, there's no difference in latitude.
Oh, that's only if you look at it as a globe and think that they're the same south and north. There's a very
No,
big difference.
we're talking about difference between the GP of the sun when it goes by at noon. It's equal
Mhm.
for us.
It's still, because again, I would have to, I'm not going to argue this without like looking at again magnetics and everything as a whole on a model, because I think it's again where you are in the map, and even more than latitude. We're playing with latitudes again the other day, and like my girlfriend just went back to Scotland, and where she's at in Scotland, we were laughing because where she is in Scotland, you know, enjoying the kind of rainy weather, and that when you look at our US map, it's hitting the Arctic Circle. It's nowhere near where anybody lives in North America. Again, when you draw the lines across even latitude, you can talk about the differences between the North and the South, but look at the North and the North. We have to pull in a few more variables before like calling everything equal in that, and there are more variables to pull in. So
The
I'll hold the
question is,
line on
are
that.
the
I'll take you on.
variables significant? Right?
You have to look at every single thing that you're doing and see if it's significant.
A question
Sometimes
from
I
the
think I.
chat, real quick, if we
Sure.
can. All right. So, can you ask Stone
Goody.
to define what he means by the term "seeing"? Because in astronomy, it has a specific meaning.
Sure. And it's actually, I mean it synonymously, that when we talk about astronomical seeing, yes, that has to do with the air condition over your head. As in, what's the lapse rate like? What is your altitude? What's the total density of air through which you're seeing? Yes. And those factors we're taking and applying to a horizontal scenario instead of a vertical one. They are synonymous.
Awesome.
So like little things as variables, I'll give an example, and I'll do it in real life and not in like the show. But again, things like this will affect that when you're talking about optics. In the past, what I did like all day long was I graded diamonds, and to grade diamonds, especially if you're on the road, you need northern daylight, not southern daylight, not west daylight, not eastern daylight, but you actually need northern daylight. It changes the temperature, it changes the amount of fluorescence you're picking up, and you can really misgrade by buying under the wrong condition. That most people would say, what difference does it make if you hold your tray here or here at this angle, that angle, and facing this light? But it did, it made quite a difference. And in dollars, it, you know, it would add up. The same with you had to take your scale and make sure that it was perfectly level. If you didn't, if you had even the slightest thing on it when weighing something that tiny, it makes a difference. So there's like little variables that can catch you in
Sorry,
how,
Cami, I
especially
really
in
don't see how
optics.
that relates to what we're talking about here.
Only when you're talking about optics for something of a light far away and going down under again when we can't even put our hand on the light. So to me, I don't know how it relates, but it's not like your shadow set that I saw as a proof. To me, it was a observation at this point until you do proof. You know, again, because
Oh,
everybody
yes.
sees
That
sunsets
is
differently.
exactly how I phrased it. I said, look, these are observations. They weren't happy with my first presentation of my observation. They said, this isn't documented. This isn't documented. So I documented those two and made another observation. And I'm still waiting for someone
Mhm.
else to document it. You know what I mean? I'm looking for confirmation so that we can move towards more confident use of the word proof.
So,
Entirely. Yes.
So we took some measurements, got some empiric data. We concluded that the sun sets 70% above the horizon and doesn't have any corresponding speed up or consistency. So it slows down. It does the complete opposite of what you'd expect on a globe, and we would have to get some other data to corroborate. No?
You're almost there. The factor, angularly speaking, that you didn't mix in there is that it's not really one degree or 70% of the sun is seen. That's just from here. When 1,400 meters away, there's an obstruction 16 meters higher than my eye observer point, right? Even at that angle, at an upward of 1 degree, 70% of the sun is still visible as it fades out. It's even more towards the FE in terms of the trigonometry.
Right on.
All right.
Yeah.
We'll go ahead and wrap up on that. Next week, Shane will be presenting on continuing the terrestrial sphere model series. So we'll be learning more about navigation or some aspect of it.
Two sphere models next, I think.
Next Sunday. Nice.
Cool.
Awesome.
Cool.
Thank you, Stone. And as we say, get out there, get more data. So I think all the necessary instructions were included on how to participate during this. You just need a pencil and some boards to make your own artificial east-west walls. You can do your own measurements there.
Yep. It's about as basic as it gets.
Nice. And yeah, so one of my favorite things about this is that it's about the terrestrial and celestial intersections. So as we learned, you know, from the only external reference we have for measuring, you know, Earth curvature or Earth flatness is the positions of the celestial bodies, and it's been, you know, mutually exclusive. Well, we're told that this is mutually exclusive to a globe, and everything we see just only happens on a globe. And it's like, well, when you measure when you do the measure the angle back to the vertex, it doesn't invert. Like that's so. Like that's game over, man. Their entire model depends on that inversion. It depends on that little hill, that little ridge line, you know, being higher than your window later on, and there's just none of it's there.
It is a key difference between the two scenarios, isn't it? Yeah.
Yeah,
Very much so.
That was a fantastic breakdown, dude. The vertex thing, I must have missed that if you've explained that before, but this iteration was fantastic on that.
It is my absolute pleasure, and I'm overjoyed that you people are getting more out of it every time we cover it. That's great,
Dude. Every time there's another little piece. That's how it goes.
And thank you for going back over again when I stopped you and did that, because it really just hearing it, because it was my first time hearing it the second time clicked it in.
No, that's good. You represent a large part of this viewing crowd today. There's a lot of people tuning in today who have not seen it before, have not been at the Clubhouse debate, have not seen any of my videos yet. You know what I mean? Those people are out there, and it's good that we get right back to the basics and make sure all the fundamentals are covered so that people understand where we're going with the data. That's a good thing.
Yeah. All right, Karen, what do you got coming up this week? Doing any shows, live streams?
Just going to do coffee talk and Monday morning probably. And I think I'm going to be on episode 500 of Strange World with Mark Sargent.
Nice.
So I think that's going to be August 5th. So
Awesome.
Not
awesome.
this week, but next week.
Cool.
Cami, you got anything coming up this week?
Oh, I did a record for a podcast with Bio Charisma podcast. We did a show before called Magnetics that we went off topic, and his machine and everything broke down on us. He also has a lot of magnets on his desk, so his stuff shut down entirely during it. And instead, we decided to record and do it as a podcast. So he said he would be editing it up. We also went off topic on that. In the chat, we had some crazy people asking for a Prezi, like on the magnetics and that on the quadrupole. I am currently, because I am outside in 95 degrees, my office did get wiped out in Hurricane Helene, but my son is setting me up an office with multiple screens. I can no longer have them outside. So we're talking about, I will go into a room for you guys on the inside, which is asking a lot from me. But I am getting set up that in probably like 2 to 3 weeks, I'll have the multiple screens and this stuff I need to present and do it without making, again, where I can actually run it myself. Because I'm running right now on a little iPad.
You're
And
saying
it's
we
lovely.
got Cami presentations incoming.
Incoming, be scared, be
Nice.
very, no, very, very simple, but yes, just some basic stuff.
Can't wait.
And a couple other things going on. Mostly enjoying the summer and that. But yeah, we do have a festival in the works that we'll talk to you all about probably more next week up and coming.
Oh,
And we're
right.
working on some details for that, so it's getting to be a lot of fun.
Nice. That's always
Um,
exciting.
Well, the
mhm.
website's up right now. We don't have the promo up, but the website's there. If anybody
Oh.
wants to go check it out for
Yeah, if you want to announce it.
information.
Let's share that.
It's esoteric.world.
So yeah, www.
Oh, not esoterica.world. My bad.
So it is.
Esoterica.world.
I noticed too that Nathan got the Facebook page up or something up on Facebook, an event that says if you're going and doing a little bit about the event, and we're getting the website up, the promos and the work, and we have for people just to tease you a little bit. Can
We do have
tease them a
people
little?
booked. Yeah.
We do have people booked. Some of the
Mhm.
people booked that you guys might be near and dear to are, we do have Mr. Austin Whitsick coming and joining us on it. Esoterica is on rare and little known knowledge and getting into unveiling the hidden. So it's a fun little thing. We do have Whitsick coming. We have Mario Gaza with his symbology and different breakdowns, which are fantastic. We have several other people that we want to slowly announce, but we do have like
Yeah,
Chief
Mario's
Pro.
channel is symbolic studies. So people might be familiar with that.
Really good one on symbolic studies. I know we have Chief Pro coming out and doing music. We have is One Big Love going to be there this year? Have we talked to Jason or
I have asked him, but he hasn't given me the yes or no for sure yet.
for sure yet? And we have Lowry. We have some different bands. We have
Lowry, we have Chris Crum.
we have DJ Curious says that he's going to probably be out here. We'd like to get some of you guys as we get there and get it going, and that as we're going. I would love for Stone, you don't get to meet and greet us, but Shane and Alan, I would love like nothing more than to like come and get to meet you in person and that. So if we can get it together a little bit more, save the date open for that weekend.
Yeah, I'm a little far away.
You're a little far away. He's a little bit long time. Though we brought Eero in from Argentina before, but yeah. Shane, you
Alright.
have no excuse. You're
Attendance
you're
is
a
mandatory
cheap
for
airline.
you.
And Alan, aren't you in Florida?
No.
Do I have you in-
Hey, up north.
No, you did go back up
No.
north. Okay, so you're
Yeah.
gonna be the hardest one, but yeah. Shane, I know that they run like cheap. My Facebook or whatever, Google keeps on bombarding me with cheap flights between
Yeah.
your area, like again, it's like, huh? Okay,
So
yeah.
check out esoterica.world. I'll
World.
put a link there in the chat. Stone, what do you got coming up this week?
Jeez, I don't know. Nothing.
Not
Just
working on
hanging out.
anything in the lab. Okay. Not
No,
anything
it's
brewing.
more. I am doing something in the lab, but it's more for personal business than flat Earth these days. That's for sure. I'm
Gotcha.
a bit of a
Ted.
deadline right now.
Gotcha. Shane, what do you got coming up?
Whatever's going on Tuesday. Someone will be doing a press on EtherCause about something awesome.
Well, so Monday we have the Celestial Theodolite update number 13. Tune into that one. That's going to be a good one. And then Tuesday will be something related to that or something entirely different. We'll see what happens.
Everyone should check out the interaction with Ruhif on the Celestial Theodolite, and that was pretty good. If anyone wants to see that.
Lose an hour of your life. Yeah, go for it.
I like it that you've had these things pressies. So it's like I told him, I said, no, we have to do a pressy. So we got to like set up at some point to do it.
If you notice, Stone's document was
Stone's document was Prezi, dude.
Excellent.
Nice. I'm glad it's caught on. All right. Well, we'll see you guys next Sunday. And then on the other channels, we'll see you throughout the week.